fun stuff ahead. My personal favorite joints to lecture and talk about because in addition to being cool, these things are useful, okay? Remember, my job, or the way I view my job, is to introduce, develop, and master more than just robot work. Like we gotta get you into functional task world. And functional task in your life may be sport and exercise. But remember, a majority of you, whether you realize it or not, most of you get into this field because of sport and exercise. But the majority of you are going to put food on the table by working with old people. That's the bottom line. And first of all, old people are super fun. They're going to say what's on their mind. They're going to make you laugh. But they need your help. This is, if you think about how often someone tears their ACL, as opposed to how often an older population need help with their posture and with broken things and with hurt things. And so you got to go where the money's at, and that's, home health. So understanding human motion more than just sport and exercise, and understanding it for function. Cooking, cleaning, working, tying shoes, putting on clothes, just how the body, specifically in this lecture, the elbow, the radial ulnar joint, help to reposition your hands to do stuff. That's what this lecture is about, okay? So, first of all, I'm going to lecture on the elbow and radial ulnar joint kind of together, but the first thing to keep in mind is these are two totally separate joints. Precedent would be like the ankle and subtalar joint, where they live close together, but they are two separate things that move two separate ways. Very similar here. Elbow, radial ulnar joint, and for even further down, the wrist, because the wrist gets credit for stuff that it doesn't do. It's like, thank you for the love, but I don't do that. I give you an example. When people like moving your wrist, that's not your wrist. So I may throw in wrist stuff just to try to emphasize exactly where these motions are actually happening, coming from. Okay. So first things first, the elbow. What is it? What articulates with it? How does it move? It is a uniaxial hinge joint. Hinge is layman's terms. Ginglinus is the Latin term. But it's a door hinge. It's not modified. We don't have to modify it to be able to kind of rotate a little bit when we torque it, because we don't run on our hands. I don't want to know about your hobbies. We really just need it to function as a traditional hinge. Just like our little finger. Just like this, hinge. So, what articulates the elbow? This is why I have this schematic up here, because of some illusions. Look at the difference between, first of all, bones, right? We got humerus, we got ulna, and then we're going to talk about the radius in a little bit. And then you have these little special areas. We've just precedent with this before, right? The malleoli are just areas of your tibia and your fibula. The cadiana is just an area of Louisiana. So this trochlea, capitulum, those aren't different bones. Those are just bony areas that help to articulate the elbow joint. Notice this difference, though. Notice that huge gap. All right. I mean, that's like the Michael Strahan of the elbow right there. Okay. In other words, if you look at how the ulna articulates with the humerus, there's no space there. That is a. But you look at all that space between the radius and the humerus. That is a heck of a lot of space. Because the radius doesn't with the humerus. The radius is there and needs its space because the radius just rotates. It's like a little clock. The head of the radius is like a little clock that spins. So in terms of articulation of the elbow joint, we're just looking at ulna and humerus. We're just looking at this. The radius, although it lives in the same capsule, its job function is very much different than the ulna and the humerus. Okay? So in terms of the bones that articulate the elbow, we're just looking at ulna and humerus. Now, a different view of this will show you something that I think is super duper cool of that olecranon. Let me get a different view of it though for you. I'm fascinated with the olecranon. The olecranon is cool. I would totally invite it to my birthday party. All right. So check this out, guys. What does that remind you of? That reminds you of a patella. And that's because it is the upper extremities version of a patella. I wish I had a better view. Watch this, how cool. Let's go X-ray. And watch how that olecranon, well, if I can get it. There we go. Look at the picture on the top right. So basically, this is an elbow that would be looking like this. That olecranon is a fused, unevolved patella. Like, in other words, your patella is part, but it's part of a bone that over time has evolved off and kind of sits and floats in that tendon. It had to because of the rotation that we do in our knees. It couldn't stay connected. Does that make sense? It couldn't have stayed hooked because of the rotation that we have in our knees. It gets snapped off. But because our elbow doesn't rotate in the same articulation, you literally have your upper extremities patella being that olecranon process. Okay? That is our upper extremities patella. So in terms of the sagittal plane, it works the same way. Into fetal, out of fetal. Flexion is going to get you in the fetal. Extension is going to get you out of fetal. The tricky part here, it's not even tricky, but elbow flexion in anatomical position, you flex and parts that go along for the ride go anterior, knees flex posterior. That illusion is going to really play out for the rotation, right? Remember for the hip, where foot comes in, instinct is to say internal rotation, but it's actually the opposite. And that's why. Because our elbow flexes, things happen anterior, the hand follows the spin. That doesn't happen to the hip. The foot doesn't follow the spin. The foot goes in opposition to the spin. And so just remember that. Elbow flexion, elbow extension, fetal, out of fetal, fetal, out of fetal. Pretty simple enough. The radial ulnar joint. This is where the magic happens. Because for function, and when I say function, activities of daily living, activities of daily exercise, activities of daily sport, however you play, or however you want to apply this stuff, your functional circle of reach, I need to be able to get my hand in a 360-degree bubble within my bubble. I need to be able to put my fingers in my palm, whether it's to defend, whether it's to work, whether it's to reach, to grab, to catch. And that's where your radial ulnar joint comes in. Your radial ulnar joint, literally, its job is to flip your hands and do it all by itself, if you have to. The radial ulnar joint's job is literally, now I'm doing this extreme example. Obviously, it could be any infinitely many sub-angles, but your radial ulnar joint's job is to get your hands facing the ceiling, the face of the floor, just like that if you need to. That's what it does. Now, how does it do it? A couple things to keep in mind. First of all is that the radius, that R, circle that R, or take mental note of that R. Radius rotates That's what's actually rotating. And remember, when we say rotate, more pure rotation, right? More spin where there's no general motion, where there's no linearity, there's no up, down, front, back, left, right. Let me explain what I'm talking about. Elbow motion. It's a general motion, right? In other words, yes, there's some of that is rotation, some of that is translation, bringing it up, bringing it forward, and bringing it back. There's no way I can curl 70 pounds. No way. But you know what I can do with 70 pounds? I can do this with it. Because it's pure rotation. I'm not having to bring it up. I'm not having to bring it down. The merry-go-round is heavy, but you can spin it. The 2,000-pound log on the water that the lumberjacks play with, they can spin it because it doesn't take a lot of force when you're not moving the center of mass, when you're not making it go up, down, left, right, front, back. That's what the radial ulnar joint does. It's more pure rotation. Radius rotates. So how does it rotate? First of all, the head of the radius is built very circular like a clock. Notice that purple hyaline cartilage, that is articulating surface. That is stuff that is designed to move smooth with as little friction as possible. Notice the space. Again, the space is important. It has distance from the humerus so that it can do its job as a spin. Now, even though the head has pure rotation, unfortunately the rest of the bone isn't as much because the radius wraps itself and unwraps itself about the ulna. Very similar to if a couple, right? Let's say a couple is laying in bed and the person on the outside, lateral side, wraps themselves about their partner where your head stays on the pillow, but maybe your body wraps, okay? So we could kind of look at the radius and radial ulnar joint. Let's see. Spoonation, does that make sense? Think about it. You can wrap your body around, but yet keep your head on the pillow. And unwrap your head around and keep your head on the pillow. That's what's happening here. The radius wraps itself around and unwraps itself around, but yet the head stays in the same place, stays on the pillow. It's a uniaxial pivot joint, that's the technical name for it. One axis, one plane, two motions. Pivot meaning that its motion is about its polar axis. It's very special. Here's a way to look at it. The elbow and the radial ulnar joint are both uniaxial, but they're not the same joint. Just like that door is a different kind of door than a revolving door. Anybody go to like fancy hotels and they have like the revolving door, right? I used to love those as a kid, man. They're doors, they're joints, but they're different. One's more pure rotation. The other has a combination of translation and rotation. Now let's talk about motion. Bless the hearts. Again, I get it. It's easy, but it's not right. And I'm not like soapboxing. I'm just saying that sometimes when you're introduced to these words, it makes it easy to describe in one scenario, but human motion is infinitely many scenarios. So how many of you have ever been taught that supination is like making a soup bowl? Right? Has anybody ever heard that before? Okay. That's good if you haven't, because that's like ridiculously simple to what's really happening there. Okay? What pronation and supination is, it's prone. We know what prone and supine is. Supine versus prone. Prone, you're laying face down. Supine, you're laying face up. Same concept to the radial ulnar joint. So imagine an anatomical position in the radius's perspective. Anatomical position, radius perspective, it's facing forward. It's supine. When it wraps around the ulna, guess what? Those eyes now went prone. So the act of going prone is pronation. And the act of going supine is supination. That's what's really happening. And the problem is when you learn supination with this one fixed landmark, your instinct is to use global references. So what people think is they say, oh, supine is when my palms are facing the ceiling, because all they've ever been done is introduced to it like this. But I'm going to show you several examples where that doesn't necessarily match up. Okay? So what we have to look at is literally what it's about. Am I wrapped or am I unwrapped? Am I wrapping or am I unwrapping? That's what prone and supine is about. Okay? So when I'm unwrapped, when I'm in a supine position, because in anatomical position you can't go any further, those bones are parallel to each other. They're unwrapped. When I'm semi-pronated, I'm like here. And when I'm fully pronated, I'm like there, minus E1. Okay? Why this is magical brings us to the wrist. Now, I'm not going to talk about the wrist joint as a joint, but I do have to kind of talk about how the wrist kind of makes this magic happen. So we have proximal radius in ulna, closer to it, and we have distal radius in ulna, further away, right? So check this out. How many of you, the analogy that I was used, or that was taught to me is Vermont and New Hampshire. I know you guys, like, this gets crazy. But it kind of works. Watch, let's check it out. Check out how these states kind of flip-flop. Right? So what I mean by that is, Vermont, I forgot which one is which, but Vermont starts off wider at the top and goes narrow, and vice versa for New Hampshire, starts out narrow and goes wide. It's exactly kind of what happens here. Ulna starts out big and wide, and as it comes down, it becomes skinny. Radius starts out skinny, and then at the end it goes far and wide. That's important because all of these carpal bones for your hand, that articulates with radius. That's important. So here's a way to look at it. If my ankle joint represented my wrist, and me and my partner were elbow radial ulna, I'm radius, partner's ulna. When I wrap myself around, everything that's attached to me goes along for the ride. So the point is that because these carpal bones are attached to the radius, when you wrap, everything goes along for the ride, including your palm. Your palm goes along for the ride. The wrist doesn't twist. The wrist doesn't spin. This motion is not wrist motion. As I'm going to show you, the wrist does this and the wrist does this. But you cannot put your arm at your side and twist your wrist. You can try it all you want. And if you do it, we got to go to the circus. Because that's a cool party trick. You can't twist your wrist. And when you do make it twist, notice where the motion is coming from, and that's your forearm. Take your left hand, wrap it around your right hand, and do this, and feel the motion of those bones moving around. Little part, go on the meaty part. Go on the meaty part and do this. You feel those bones moving around? That's where that's happening. Now, why does it look like your wrist is twisting? Because all the things that are connected here attached to the radius. And because the radius is wrapping and unwrapping, everything that's connected to it is going along for the ride. When the radius wraps, everything attached to the radius wraps with it. And when the radius unwraps, everything attached to it unwraps with it. Thank you, Vermont and New Hampshire. You've been a hoot. Look at all this space, man. Those carpal bones aren't connecting to the ulna. They're on the radius. They're on the radius. In fact, you need all that space to kind of give you some space to do this stuff. This is not wrist. It's radial ulna joint. Okay? So, let's talk about some illusions. This is some, I say tough. It doesn't have to be tough if you practice this, but this could be challenging. This could be challenging. Because seeing this as an angle change is a heck of a lot easier than seeing this as an angle change. And not only that, the questions that I'm going to ask you aren't just going to be like this. They're going to be like this. They're going to be like this. They're going to be like this. So I have to teach you clues. It's my job. I got to teach you clues. So let's talk about clues. When you are supinated, now all of this stems from the fact that the wrist doesn't twist. If you tell me that a joint doesn't spin in the transverse plane, that's great information. Because that means I know that the thumb, which one doesn't belong, apple, banana, strawberry, pineapple, sledgehammer, right? You can all see a thumb. The thumb will always and forever be radial side. It has to. Unless you have some traumatic injury, you cannot get your thumb away from being splinted with your radius. And the opposite, your pinky will always and forever be ulna side. It has to. Thumb side, ulna side. Okay? In anatomical position, your thumb radius is lateral. Pinky is medial. When you wrap your radius around the ulna and the thumb goes along for the ride, guess who is now medial? Your thumb. Does that make sense? Guess who is now lateral? Your pinky. That's how you know. Or that's how you can prove. That's how you can cross-check to see if you're wrapped or you're unwrapped. If you're fully wrapped, your thumb is going to be on the same side as your medial epicondyle in your humans. And if you're unwrapped, your thumb's going to be on the lateral epicondyle. So again, in these simple examples, life is great. But I'm going to give you some unsimple examples that you're going to have to be able to see what's going on. Okay? Also, subtleness of the radial ulna joint. Your radial ulna joint moves so much and you don't even, and when I say you, I'm not talking about you specifically, I'm just saying people. We as people. Your radial ulna joint moves so much that we as people don't realize it. I'll give you some examples, okay? I start here, and I do this. My radial ulna joint had full pronation when I went from here to there. Full. It's subtle, and it happens in conjunction with my shoulder motion in order, in this case, I wanted to keep my palms facing forward. And if I didn't, this is what would happen. Here's another way to see what I'm trying to tell you. Palms up, right? Palms down, right? It's freaky stuff. Very subtle. Here's another one that freaks people out. Say it freaks people out. Your radial ulnar joint moves with your shoulder joints in simultaneous ways. Meaning that when you're doing an upright row and you start off in a prone position, I'm wrapped, right? Thumb medial. Superman flies in a prone position, wrapped, okay? Check this out. If you stayed wrapped, if you stayed prone when you did an upright row, it would look like this. Superman flies prone. But you know when you row, your fingers stay under the bar, right? So what does your radial ulnar joint do simultaneously with your shoulder motion? Supinates. No way, Campbell. Okay, let's do some before and after pictures. Start position. Prone. Finish position. Does my radial ulnar joint have anything to do with my elbow joint? Two totally separate joints. So I can extend my elbow and I'm still in the same position. Radial ulnar joint has nothing to do with my shoulder joint. I can adduct and be in the same position. I can flex and be in the same position. This is my new position. I started here and I finished there. It's subtle. It's subtle. And it's not traditional. Traditionally, you guys are introduced to all radial ulnar joints like this. And what I'm trying to get you to see is that we can do a lot of radial ulnar joint stuff where we don't have to do this. We can move the other parts. Just like other places in the body. Just like we did with the ankle. I can move my ankle joint by not moving my foot. Alright? This is something we will work on. I'm just introducing you to what it is, why it's important, and some weird ways it can help you. And then we will practice the ever-living heck out of being able to see what is wrapping and what is unwrapping. Okay? Alright. Follow me here. Anatomical position. Right radial ulnar joint, pronation, supination, pronation, supination, pronation, supination, pronation, supination, pronation, supination, pronation, supination, pronation, supination. Does my radial ulnar joint have anything to do with my wrist? In other words, my wrist could be here. It doesn't matter. Pronation, supination, pronation, supination. It looks different, but it's the same thing. My radius is either wrapping or unwrapping. So if I start here and do this, for someone who doesn't understand human motion, they may think that both things did the same thing because they're both looking at that end of the class and then they're both looking at that end of the class. You guys know different, but you're like, whoa, 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 I'm not going to assume. Where's my start position? Well, if we're talking about radial ulnar joint, it has nothing to do with my wrist, has nothing to do with my elbows, has nothing to do with my shoulders. I started here. My left is wrapped and my right is unwrapped. Everybody understand that logic? I have left supination and right pronation. That's how you do it. My left is wrapped and my right is unwrapped. My thumb is medial and here my thumb is lateral. There's all kinds of clues. One time, people doing some warm-ups. I forgot what the exercise was called, but they were going from, oh, God dang dong. They were going from here to there. Here to there, here to there. And from a global reference, man, I'd say 99% of people would say the only thing you're moving is your shoulders. Heck, I get it. But you're also moving your radial ulnar joint. also moving your radial ulnar joint. What's my position of my radial ulnar joint here? Am I wrapped or unwrapped? Wrapped. What about there? Unwrapped. So why is it hard to see? Because globally, I kept my palm facing down. And so you're like, well, you didn't move anything. But the reality is that I had to move something to keep my palm facing down. And that comes with the shoulder. I wanted to talk about the radial ulnar joint before I get into how the shoulder, when you go out, has to have some rotation in order for you to keep going up. Think of it like this. Articulating surface, golf ball, golf tee. The shoulder cannot abduct and just keep going, or else you're going to run out of golf ball. What I mean by that is, if the shoulder is here, you can't do this. And think about it like this. If I start here and I do this, that's the same end position as doing that. So, if I flex and I get to this position where I still have golf ball and golf tee, something has to accompany, something has to go with abduction in order to get me to the same place. Does that make sense? And that something is rotation. In other words, flexion of the shoulder gets me to the same place as abduction and external rotation of the shoulder. So now it should make sense why I need a pronate and supinate. Because my shoulder wants to spin one way, and I compensate by spinning the radial ulnar joint the other. Let's go back to that upright row. External rotation, internal rotation, external, internal. Watch how subtle. You see? In other words, I'm not going to move my radial ulnar joint. External rotation. And when that happens at the same time as this type of rotation, you're able to keep your hands in the same position. So the pronation and supination are needed to cancel out your shoulder's natural rotation when you bring your arms up by your side. I'm starting to pronate, 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 pronate. Supinate, 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 supinate. You see it? All right. Let's do a practice question. Put your hand on your head, like you're patting yourself on the head. Your hand is facing down. I want you to go from your hand facing down to your hand facing up. And then I want you to look for the clues and try to figure out, did your hand wrap or unwrap as you went from hand facing down to hand facing up. Discuss amongst yourselves, but don't answer it out loud. Did I wrap
or unwrapped? I wrapped. I'm supinating here. Here's a couple ways to see it. Here's a couple ways to see it. If my palm is touching my head up here, does it make sense that I didn't move any of my radial ulnar joints out? I could, as long as I stay connected, I could be anywhere. I'm not moving my radial ulnar joint, right? So watch this trick. It's my start position. My end position. But if you learn it as a soup bowl, darn it, you're going to think this is supination because you made the stupid soup bowl over your head. And therein lies the problem with these simplistic examples that give you just one specific area to learn these joint motions. And the reason it's important to me is because we don't work with people in robot world. People don't move in robot world. Athletes don't move in robot world. Patients don't move in robot world. They move in the real world. So we have to be able to see these things for what they are. That's reality. Okay? All right, how about a couple more? All right, how about a couple more examples? What if I started, I hinted at, I would never ask you this out of the blue. That's why I kind of teach you some stuff first before we get into some of these trickier examples. Guys, I know you're going to hopefully get what's this. I know you got that. I'm trying to get you to see more. I'm trying to get you to see more, okay? If I start here, I need you to say, where is my, and what's my position? Where am I at? So instead of starting here and coming up, I'm going to start up here and go down. Now again, why is this an illusion? Because no one in their right mind would think I had any movement in my radial ulnar joint because the back of my hand stayed facing forward. And you were taught this. So you can see how you would assume that nothing there was happening. And that's why I'm here metaphorically speaking. Moving, it has to move. If it didn't move, you'd do this. Okay? So if I start here and do this, what type of motion would the radial ulnar joint contribute in conjunction with the shoulder? Now, what's happening in the shoulder? That's a shoulder question. I'm asking you specifically about the radial ulnar joint. Start, finish. The radial ulnar joint motion is there to keep my fingers under the ball. Am I wrapped or unwrapped up here? Unwrapped. Wrapped. So what's the process of going unwrapped to wrapped? Pronation, Jack. In this case, bilateral radial ulnar joint pronation. And again, if you can't see it, one of the tricks I'm going to teach you, that's very unique to this guy, is you can bring everything back to anatomical as long as you don't mess with the joint you're analyzing. It's a big if. But if you don't mess with the joint you're analyzing, you can bring everything else back home. Elbows have nothing to do with it. Shoulders have nothing to do with it. I'm unwrapped. Now I'm wrapped. How about something like this? Softball game tonight. They're going to play the national anthem. You stand up. Now, anatomical position is kind of funny. It's not the position we're in the majority of the time, right? You don't walk around with it. Right? So we kind of talk about more of like a functional position, right? Where you're going to kind of be, kind of wrapped when you're there. But let's assume I'm at the game tonight, and they play the national anthem, stand up, take my little beanie off, and then I'm going to go from this position to this position. Now again, why is this tough to see. It's tough to see because your instinct says the back part of my hand stays facing the same way. So how in the world could there be any of this? And what I'm trying to get you to see is that if all I did was move my elbow, you'd go from seeing the back of my hand to seeing the front of my hand. The radial ulnar joint motion happens so that you can keep seeing the back of my hand in this case. It's subtle. But if all I did was move my elbow, do this. Supination is going to put me in a position to get my hand. Start here, finish here. I went from here to there. I unwrapped the sum. It's not what I really wanted to see. It's subtle, but it's extremely important. Think about it. If you don't understand radial ulnar joint motion, how are you going to help people who can't do functional tasks because they have limitations of their radial ulnar joint? You're like, I don't understand why you can't do that, Mr. Smith. You should, your shoulders moving forward. I don't understand why you can't do that. Where there's high tide, there's low tide. Meaning that you guys understanding radial ulnar joint function above the average person is going to put you in a position to have better application of your materials than other students as well. So I know now it's kind of freaky and it's different, but just trust me on this, man. Practice and learn radial ulnar joint motion. You're going to thank me later. All right? Y'all have a good Wednesday. Stay dry.